Imagine looking into a mirror that doesn't just show reflections, but remembers time. A mirror so powerful that instead of showing your own face, it reveals the universe's first memory, the moment when everything began. That is what the James Webb Space Telescope was built to do, to reach beyond light, beyond distance, and capture the dawn of creation itself. But when Webb finally looked deeper than anything before it, it didn't see simplicity. It didn't see beginnings. It saw something that should not exist, a cosmic impossibility written in ancient light. And what it found didn't just surprise scientists, it shook the very foundations of modern physics. For decades, cosmologists believed they understood the order of creation, the Big Bang, then darkness, then the slow rise of the first stars and galaxies. The rule seemed clear: the farther back you look, the simpler the universe should appear. But when Webb turned its golden mirrors toward what was thought to be an empty patch of sky, it found not a void, but galaxies, massive, bright, and organized. Not the soft glow of hydrogen clouds. Not chaotic fragments. But galaxies, spinning, structured, and full of life-filled stars, existing billions of years before they should have been possible. It was as if the cosmic clock had jumped forward. Like finding a finished symphony before the first instrument was ever built. One of Webb's earliest deep-field images captured a galaxy more than 13 billion light-years away. Scientists expected a faint blur, a whisper of light from the first era after the Big Bang. Instead, they saw spiral arms, dense star clusters, and a glowing core radiating with energy. This wasn't a galaxy forming. It was a galaxy already thriving, just a few 100 million years after time itself began. By every rule we know, this should be impossible. It's like finding a city skyline in a world where bricks haven't been invented yet. To grasp why this breaks the laws of physics, you have to understand how galaxies are supposed to grow. In the early universe, matter was thin and scattered. Over time, gravity pulled it together, slowly forming stars, which then clustered into galaxies. That process takes billions of years. But Webb's images show something else entirely: a universe that ran ahead of schedule. Galaxies didn't crawl into being. They leapt into existence, filled with heavy elements, oxygen, carbon, and iron. These elements are not primordial gases. They're forged inside massive stars and spread only after those stars die as supernovae. So if these elements were already present, it means the first stars had already been born, lived, and died, not once, but multiple times, all within the universe's opening moments. The early cosmos wasn't a calm nursery. It was a furnace of creation, forging worlds and elements at impossible speed. Then Webb uncovered something even more disturbing: a supermassive black hole, billions of times heavier than our Sun, sitting at the heart of a galaxy that existed less than 400 million years after the Big Bang. By every model, such a monster shouldn't exist so soon. Black holes are supposed to grow slowly, starting from collapsing stars, feeding for eons before reaching that size. And yet, there it was, ancient, massive, and complete. A cosmic engine that shouldn't have had time to form. This forced scientists to rethink everything. Some began exploring new possibilities: primordial black holes born directly from the fabric of the young universe, or laws of gravity and time that behaved differently in those first moments. These aren't small adjustments to theory. They're complete rewrites of how we think reality began. But Webb's surprises didn't end there. Within the faint structure of the early universe, its sensors detected strange geometric patterns, ratios, alignments, and spiral symmetries woven into the large-scale web of galaxies. What was once assumed to be random chaos started to look like mathematical design. Not design, in the human sense, but a kind of cosmic code, a repeating geometry written into spacetime itself. It was as though the universe wasn't forming by chance, but by some hidden order embedded in its earliest light. Then came something even harder to explain: traces of complex organic molecules drifting in empty space. Not just simple gases, but long carbon chains, the seeds of amino acids, the chemical ancestors of life. These weren't found on planets or stars. They were floating freely between galaxies, carried through space for over 13 billion years. That means the building blocks of biology didn't emerge late in cosmic history. They were there almost from the beginning. Maybe life isn't a rare accident. Maybe it's a built-in feature of the universe itself. Among Webb's strangest images was one scientists nicknamed the cosmic flower. 6 galaxies arranged like petals around a central mass, evenly spaced, moving in near-perfect synchronization. The odds of this happening by chance are microscopic. Some call it a trick of gravitational lensing. Others say it's coincidence. But for a few unsettled minds, the symmetry looked too deliberate, as if it had been placed there, waiting for eyes like ours to finally see it. And then came the most unsettling idea of all, that the act of looking might be changing what we see. In quantum physics, the observer can alter the outcome of an experiment. But what if that principle scales upward, to galaxies, to spacetime itself? Some Webb images have shown subtle variations between data runs, tiny shifts in alignments and brightness that shouldn't be possible. Could the universe itself be responsive to observation? Could our attempt to look back in time have awakened something that remembers being seen? The James Webb Space Telescope has revealed galaxies too advanced, black holes too massive, and chemistry too complex for the universe we thought we knew. It hasn't just stretched our theories, it has broken them. And in their place rises something deeper, a realization that the cosmos might not just contain meaning, it might be meaning. Maybe we didn't just find the universe's memory. Maybe, for the first time, the universe remembered us. So the question is no longer, what did Webb discover? The real question is, what discovered Webb? If this discovery unsettles you, if the timing feels too perfect, the patterns too deliberate, you're not alone. Subscribe and stay alert. Because the next signal could already be on its way. And the universe may not be done speaking back. It might be meaning. Maybe we didn't just find the universe's memory. Maybe, for the first time, the universe remembered us. So the question is no longer, what did Webb discover? The real question is, what discovered Webb? If this discovery unsettles you, if the timing feels too perfect, the patterns too deliberate, you're not alone. Subscribe and stay alert. Because the next signal could already be on its way. And the universe may not be done speaking back.